Double angle identities. These formulas are given to you on your reference sheet and on an exam that you would take. So let's get a little bit of practice with them. Cosine theta is 3 over 5 and sine theta is less than 0. What this is telling us is basically the quadrant. Where is cosine positive and sine negative? Where I know cosine's positive here, nothing else is, so sine would be negative there. So we're talking about quadrant 4. And the reason why that's important is because the formulas often need, the cosine theta, but they also need sine of that angle. And so if I know I'm in quadrant 4, and I know cosine's 3 over 5, that's adjacent over hypotenuse, and I need that missing side. It's a y value. We see this is a 3, 4, 5 Pythagorean triplet. So I know that this is going to be 4, but I also know because it is below the origin on the y-axis, it's going to be a negative 4. Plus, I know sine has to be negative in quadrant 4, so opposite over hypotenuse for sine is going to be negative 4 over 5. So now that I have cosine theta and sine theta, I can do pretty much everything I need to on my formulas. The formula for sine 2 theta is 2 sine theta cosine theta. So that's 2 over 1 times sine theta is negative 4 over 5 times cosine theta is 3 over 5. And I can let my calculator do a lot of this for me, or I can just multiply across the top and simplify. And that's what I'm going to do here. I'm going to multiply just across the top. 2 times negative 4 times 3 is negative 24. 1 times 5 times 5 is 25. Cosine 2 theta actually has a couple of different formulas you have there. You could do cosine squared minus sine squared, or you could do 2 cosine squared minus 1, or you could do 1 minus 2 sine squared theta. There's a lot of options there, and sometimes if you're doing an identity, you have to pick a particular one. I'm going to go with 2 cosine squared theta minus 1. 2 cosine squared theta minus 1. So I actually don't need the sine value here, but I did for the other one, so it's good that I had it. So this has 2 over 1. Cosine squared, see cosine is 3 over 5, and we're squaring that minus 1. So 2 over 1, 3/5 squared is 9 25ths minus 1. Let's see, 2 over 1 times 9 over 25 is, multiply the top, we're going to get 18 over 25. Now minus 1, I can just turn 1 into any number over itself, like 25 over 25. This way my two fractions have a common denominator, and I see that 18 minus 25 is negative 7 over 25. All right, and lastly, let's do tangents. Just create some space here. Tangent to theta. And first of all, for tangent theta, we do need to know what tangent of our angle here is. We did get sine and cosine, but we need to know what tangent of the angle is. We know tangent is sine over cosine. So let's see, that's going to be sine, negative 4 over 5 over cosine, 3 over 5, multiplied by the reciprocal on top. So we flip that, get rid of these, and we get negative 4 over 3. So tangent theta is negative 4 over 3. The double angle formula for tangent is 2 tangent theta over 1 minus tangent squared theta. So let's see, let me use a different color here, a little too much red. 2 tangent theta, that's going to be 2 over 1 times negative 4 over 3 over 1 minus negative 4 over 3 squared. Let's see, the numerator is going to be negative 8 over 3. My denominator here, let me see, I can simplify this. Let's see, 1 minus negative 4 over 3 squared is going to be positive 16 over 9. And then I can make 1 into 9 over 9. let's see, 9 minus 16 is negative 7 over 9. And using my reciprocal, I'm going to multiply this by 9 over negative 7. And let's see, I can let my calculator do that for me. I know it's going to be positive because we got a lot of negatives, so let's see. But I'll keep that in there. Negative 8 divided by 3, close my parentheses, times 9 divided by negative 7. Close my parentheses, enter, and convert to a fraction is positive 24 over 7. And that's it.